Hi, in this video we're going to continue our dive into Booleans, and we're going to look at operators, we're going to look at operator precedence, and we'll also look at what short circuit evaluation is and how it works. So first of all, the Boolean operators are not, and or. And here's a truth table, and if you haven't seen a truth table before, it's actually pretty straightforward. We just list out all the possible combinations of our input variables. In this case, I'm looking at two input variables, x and y. So the variables can be false or true. I'm using a 0 for false and a 1 for true. So if x is false, then not x will be true. Not false is true. Similarly, not true would be false. Or if we have two input variables like x and y, or x or y, well, if we take false and false, that will be false. And false or false would be false as well. On the other hand, true and false would be false, but true or false would be true. So that's just what a truth table is. It's just a pretty straightforward way of listing out all the possible combinations of your input variables and then listing out what the result of whatever Boolean expression is. Another way to also look at these Boolean operators is to think of electrical circuits and to think of switches in an electrical circuit. So here's part of an electrical circuit. Let's say we have current that's coming into this side on the left, and we have a switch. Now the switch can be open, in which case no current is flowing out of the switch, and so we would consider this to be in a false state, right? The result would be in a false state when our switch is open or false. On the other hand, if we close the switch, when the switch is closed, we consider the switch to be in a true state, and it actually allows current to flow through. And so if we have current coming in on this side, then we have current coming out on this side, and we would consider that as a true result. So the OR can be expressed as two switches in parallel. And so X or Y means that current is coming in, and then it bifurcates, and it flows through both branches here. So you can see that if X is closed, if X is true, then the current will actually flow out of the switch. And so we end up with a true result. So this is the situation we have here. X is true and Y is false. It's open. And yet the result of our operation, our OR operation, is 1, is true, right? So this is how it works. So if X is true, it doesn't matter what the state is of the second switch. The result will always be true. And in fact, we see that here. Right? If X is true, then the OR is always true, irrespective of what Y was. Now similarly, we can look at and we can represent as two switches in series. And again, we can just make their Boolean values something, so we can keep X open, which would be a false, and we can make Y closed, which would be a true. But you'll notice that if either of the switches are open, then the current can't flow through. There's no way it can. So when X is false, let's say it's these first two rows, then it doesn't matter what Y is, the result will still be false. So we have this result here, false and false. Okay? All right, so let's look at some properties of the Boolean operators. So let's look at commutativity. Now, commutativity just means that A or B is the same as B or A, and A and B is the same as B and A. It doesn't matter in which order you do that. We also have distributivity. So A and B or C is the same thing as A and B or A and C. We can distribute this A and throughout this expression inside the parentheses. And then same thing here. A or B and C is A or B and A or C. So hopefully you've seen all these things before. I'm just refreshing your memory. Now we also have associativity. Now associativity just says that you can group your OR operators, if you have multiple, in any order you want, that it doesn't matter. So A or B or C is the same thing as saying A or B or C. And so therefore we can write without any ambiguity A or B or C without parentheses. Now when we evaluate it, or Python evaluates an expression such as this, it will have to pick an order in which to evaluate the ORs. It's going to have to pick one, right? And the same thing happens with and. A and B and C is the same thing as A and B and C. So again, we can write it without any ambiguity as A and B and C. And so what's going to happen with Python, it's going to do a left to right evaluation. So in this case here, it's actually going to do this. It's going to evaluate A or B and then OR it with C. And the same thing with A and B, it will evaluate that first and then AND it with C. But of course it doesn't matter which direction you do it in. If it's left to right or right to left, they're all exactly equivalent. Then we have De Morgan's laws, which basically tells you how you can distribute the NOT operator inside this parentheses. So not A or B gives us not A and not B. You'll notice that when we did the distribution of the not, the OR changed to an AND. And then the similar thing with AND, except that the AND changes to an OR. So those are called De Morgan's laws. And then just a few other miscellaneous things that also might be helpful when you're trying to look at Boolean expressions and maybe trying to simplify them so that you can make your if statements, for example, a little easier to understand. Keep in mind that not x less than y. So if x is not less than y, it means that x is greater than or equal to y, right? So the not of that becomes this operator here. Similarly, if we have not x less than or equal to y, so if x is not less than or equal to y, really it just means that x is greater than y. And then we have the same thing with the other, with the greater than and the greater than or equal to. It works the same way. We just flip the operator around and then we add or remove the equal sign depending on where it was. Also, not A is the same thing as A, so a double not just comes back to the original value. So let's look at operator precedence now. And I'm including the parentheses even though they're technically not an operator, but they do play into the precedence of operators, and we'll see that in a second, and you've seen this before already. Anyways, so here we have some operators. These are comparison operators like less than, greater than, equal to, not equal to, in, is. We've seen all these operators before. Then we have not, we have and we have or. And the way that I've listed all these things out is that this is in order of highest to lowest precedence. What does that mean? Well, let's look at an example. Let's look at this expression. So we need to start evaluating this expression. But where do we start? Do we do true or true first and then AND it with false? And the answer is no. AND has a higher precedence than OR. So in reality, we have to evaluate true and false first. So that's the first thing we do. So now we end up with true or false, since true and false is false. And now we can finally evaluate true or false, and we get true. Now, this is not the same as if we had done the other way. And so to make this clear, let's put true or true. This will now force the OR to happen first, which wouldn't have happened here because of the precedence of AND being higher than the precedence of OR. In this case, because of the parentheses, we have to evaluate that first. So we're going to evaluate true or true. And true or true is true. And then we AND that with false, which ends us with false. So as you can see, the order in which the ORs and the ANDs are evaluated in an expression like this matters. It makes a difference. So because of that, we need a precedence, essentially definition that tells us, well, in the case where you haven't specified these parentheses, what order should happen, what order should be used. So that's what the precedence is for. But when in doubt, or to be absolutely sure, use parentheses. There's nothing wrong with putting a few extra parentheses in your expressions if it helps make it clearer. For example, it's perfectly fine to write true or true and false. That's okay. And yes, you technically don't need the parentheses, but it's more readable. You can understand what's going on. And that's a key part to a lot of code, is you really want to try and make your code not just efficient for the machine to handle, but you also want to make it human readable. Humans are going to read your code. Other people are going to read your code. You might read your own code, and if you do it 6 months later and you made it very difficult to understand, you'll probably be looking at it, scratching your head, saying, what was I thinking? I know it happens to me all the time. So it's important to make code human readable. And comments is one way of helping, but that's not the only way. just having nicely formatted code, simplified code makes a big difference. For example, look at this. Look at this expression here. A less than B or A greater than C and not X or Y. I'm sure you're scratching your head thinking, oh, what is this thing doing? And you know what? So is Bob. Bob's really confused. It's like, what's going on? And of course, we want to make sure Bob's not confused. So let's take a look. Well, the precedence here means that the less than and the greater than have to be evaluated first. So those expressions are going to be evaluated before any of the other ones. Then next in the order of precedence is not, and here we have this not X. So that will get evaluated next. So now we have some value, let's say X, or let's say capital A, or capital B, and capital C, or Y, right? That's kind of what we have. So we have these OR, and OR operators that are left. Well, again, AND has a higher precedence than OR. So we have to evaluate now this AND first. And now we're left with just something or something or something. And as we saw before, it doesn't matter now which order you do the ORs. It's A or B or C. It doesn't matter, right? So in this case now, we could really have rewritten this expression equivalently this way, as a set of parentheses, A less than B, or some expression, or Y, because that whole expression is in parentheses. And then inside of that, we have furthermore that it's calculated as A greater than C and not X. So it's a lot simpler to understand what's happening in this piece of code. And of course, Bob's happy now because he gets it. All right, so my point is, don't write things that are confusing. And one of the things that's easily confusing in code is writing Boolean expressions without parentheses and only relying on precedence of operators. Yes, it's fine. The machine will get it, right? The machine doesn't care if you write it this way or this way. Python interpreter will work equally well with both. But humans are going to have an easier time reading this second one than this first one. So, enough said. I'll keep quiet on the subject from now on. But let's now go and look at short circuit evaluation. Let's look at OR first. We've seen this truth table before. And let's go, think again, and something this is something I've pointed out before, but you'll notice that the result of OR is true in both these cases, and it was because X was true. Remember, if we think of it as a switch, when X is true, then the result is true no matter what Y is. Y can be true or false, it doesn't matter, current will still flow through the switch. So if X is true, then X or Y will be true no matter the value of Y. In other words, another way of saying this is that X or Y can return true without evaluating Y if X is true. And so that's what happens. If X is true, then we can return true without even calculating Y. That's short-circuiting the calculation of Y. We're short-circuiting the evaluation of Y. It works the same thing with AND, the same way, except that with AND, you'll notice that we have always a false value when X is false. So if you think of switches again, if X is false, which means the switch is open, then it doesn't matter what the state of Y is, if it's true or false. The result will be false because nothing can flow through because of the first switch. And so if X is false, then X and Y will be false no matter the value of Y. Again, we can see this in the truth table over here. Another way of saying that is that X and Y will return false without evaluating Y if X is false. So again, it's short-circuiting this evaluation of Y when X is false. It doesn't need to because we don't care. It doesn't matter. So that is short-circuiting. And that can be useful in a number of cases, a number of scenarios. So let's take a look at the first scenario. Let's say that you have a data feed of lists of stock symbols and some maybe associated financial data. Maybe it's the number of shares traded or whatever it is. This is just an example. So suppose that you've got this feed of data that you're getting and you've got stock symbols that come in. And your job is to monitor the feed looking for some specific stock symbols. You're only interested in a few stock symbols out of the thousands and tens of thousands that are coming through. You're only interested in a few. And you also want to take some action if the price of that stock is above some certain threshold. But getting the current price of a stock, and that's the caveat here, has a cost. Maybe it's a hard cost. Maybe every time you make a request to say, hey, give me the price of Apple at the moment, it's going to maybe cost you something. Or maybe it costs you something in terms of resources. You have to open up a database connection. Or maybe you have to set up an HTTP connection to an API, and then you got to make a call to the API, and that API has to make a call to some database somewhere. So the point is that there's a cost associated with getting the price of that symbol. So let's see how we might code this. Let's assume we didn't have short circuiting at all. Then you would probably write it this way. The first thing is you would have an outer if symbol in watch list. All right, so the first thing is the symbol one that we're interested in? So this watch list would be a list of symbols, right? And we're going to check to see if the symbol we just received in the feed is in that list. If that's the case, now we go and retrieve the price. And if the price of the symbol is greater than some threshold, then we go ahead and do something or other. So the thing here is that calling the price method has a cost. So you don't want to call the price method every time. You want to, make sure that you're not racking up your cost looking up the price of a symbol that you're not even interested in. So we could write it this way. However, if we do have short circuiting, we can write it equivalently this way. If symbol in watch list and price of symbol is greater than threshold, do something. Well, that's equivalent because of the short circuiting. If the symbol is not in the watch list, then this will evaluate to false. And because of short circuiting, false and anything is always false, this will actually not get evaluated. Python will not run the spout of the AND statement because it says, well, I don't need to know, this is false. So I can basically skip the spout and just return false. And this result of this if statement's expression here would be false, and we wouldn't execute the code. Of course, on the other hand, if the symbol is in the watch list, then this returns true. At that point, there is no short circuiting and when your first operand is a true. So it's going to have to evaluate the second operand of AND. And so now it will go ahead and run that. Okay. So at that point, this runs, but only if this thing here is true. If it's false, it never runs. And so it's equivalent to writing this nested if statement. All right, another example might be, let's say you're returning a name from a database, and let's suppose that it's a nullable string. So your name can be in 3 different states, right? It can be a null, which means that typically you would end up with a none object in Python. It kind of depends on, the database connections you're using, or at least the database API that you're using, the library, and so on. But typically, null in the database translates back to a none object in Python. Or it could be just an empty string. It's okay to have an empty string in a text field in a database. So it might be that. It's not the same thing as null though, right? None and empty string are not the same thing. Or it could actually contain characters. So those are the 3 possible states of name. And let's say that we want to perform some action if the first character in the string is a digit, right? 0 through 9. So you might be tempted to write something like this. We might write if name 0 in string.digits, and that just takes the first character of name. And string.digits, well, string is a module you can import, and digits is just a string that contains 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll see that in the code when we switch to that. But this just basically checks to see, is the first character of name in one of those digits? Is it a digit? If it is, do something or other. Well, this is okay, but it's going to break, right? It's going to break if name is none or if it's an empty string. If name is none, well, none doesn't have, you can't find an index. None, the none object is not a sequence type. It's not indexable. Same thing if the string is empty. Yes, at this point you can use indexes, but since the string is empty, there is nothing in position 0. That is also going to break our code. So that's not going to work. What we need to do is to really say, well, I want name to not be none, to also not be empty, and then and only then do I want to check if the first character of name is a digit. So we could just write it this way, by using short-circuiting and truth values. If name and name0 in string.digits. So let's see what this does. Well, first of all, name is an object, but we're looking at the truthiness of this object. And remember that name will be false if it's none. None is always falsy. Name will also be falsy if it's an empty sequence, and otherwise it will be truthy. So look at what happens here. If name is falsy, then because of short-circuiting, this does not get executed. Name0 does not get evaluated. So if name is truthy, then it evaluates name of 0. But name can only be truthy if it contains characters. Otherwise, it would be falsy. It would either be none or an empty string. And so we're only going to execute the second part here, which was the one that was causing us a problem, if it's okay to do so. All right. So if the name is falsy, I'm just going to repeat this, either none or an empty string, then this is not evaluated because of short-circuiting. So short-circuiting can be really, interesting, and we'll see some more examples of short-circuiting coming up in a future video where that will also be quite useful. All right, for now, let's jump into the code and just take a look at all this in action. So we'll do that in the next video. I'll see you in a bit.